So we have an example for the topic simple vapor compression cycle. So example number 1, a simple saturated refrigeration cycle for R12 system operates at an evaporating temperature of -5 degrees Celsius and a condensing temperature of 40 degrees Celsius. Determine A. The refrigerating effect per kilogram, B. The work per kilogram, C. The heat rejected at the condenser per kilogram, and D. The COP or coefficient of performance. So, ang ating refrigerant in this case, so we have refrigerant, okay. So, our refrigerant is R12, no? So, and then we have temperature or evaporating temperature or evaporator at the condenser, that is -5 degrees Celsius. And of course, we have condensing temperature or temperature at the condenser, which is 40 degrees Celsius. Now, to solve this problem, no, kailangan natin ng mga values, especially yung values ng specific enthalpy. So, titingin tayo sa refrigeration tables and charts. So, we will be looking for the values ng -5 and 40 or values ng enthalpy and other properties at these temperatures using the R12, no? R12 table. So, in this case, ang gagamitin ko is yung ASHRAE. Okay? So, ASHRAE table. So, by looking at this point, no, kung gagawa tayo ng diagram, so this is your, of course, condenser. Okay. Okay, this is your evaporator. Medyo maliit na lang yung drawing. This is the compressor, and then this is your evaporator. Point 1, this is point 2, point 3, and then point 4. Okay? We recall that at this point, this is P is equal to C, no? So, sa evaporator, dyan po magkakaroon ng refrigerating effect or QA. And then we have, in this case, we have S is equal to C. And then sa compressor, of course, need niyang work ng compressor. Okay? Then from 2 to 3, that is under P is equal to C process. And magkakaroon po dyan ng heat rejection. So, ito po yung ating condenser. Then, from 3 to 4, we have expansion at H is equal to C. Okay? So, since kailangan natin ng table, so, titingin na lang ako at point 1. Let's say, at point 1, we have, this is yung suction sa compressor or exit ng evaporator. So, we can say that, ideally, at point 1, ang condition is saturated vapor. So, we can say that H1 is equal to Hg at what? At T evap, or that is what? Hg at -5 degrees Celsius. So, looking sa table, nakakuha ko ng value na 350.56 kilojoules per kilogram. Okay? Consequently, we will be having S1, or we're looking for S1, that is Sg, kasi nga saturated vapor at T evap, no? T evap. So, that is Sg at -5 degrees Celsius. So, that is 1.5618 kilojoules per kilogram Kelvin. So, again, ginagamit ko is from ASHRAE. And baka magamit, I'll be looking also for specific volume at point 1. So, again, this is V sub G or saturated condition, no? Vapor condition at T evap. So, that is V sub G at -5 degrees Celsius. So, that is equal to 0.0654645. Okay, cubic meters per kilogram mass of the refrigerant. Okay na. So, that is your again, yan na yung mga values for point 1. Now, try ko muna mag-proceed sa point 3. Kasi at point 3, we all know that at 3, in ideal condition, this is saturated liquid, no, condition. So technically, H3 is just H sub F at T ng condenser. So this is HF at what? At what temperature? At 40 degrees Celsius. And looking sa ASHRAE table na, ASHRAE provided table, so we have 239, okay, sorry for that, 239.22. Again, so unit is kilojoules per kilogram. Okay, so yan ang ating H3. Okay, and at point 4, of course, kailangan lang naman natin dyan is yung H4. So technically, no, 3 to 4 is isenthalpic process. So H4 is equal to H3. That is equal to 239.22 kilojoules per kilogram. Okay? Now, at point 2, so ideally that is saturated vapor, no? So, ano ba ang pwede natin kunin dyan? So, we can say that S2, okay, is equal to S1. That is equal to 1.5618, no? Kilojoule per kilogram Kelvin, okay? And then, paano natin kukunin si H2? So, H2 can be found using yung chart, no? So, that is H at what? At T2, or, sorry, T condenser. Ito po yung gagawin nating reference. T condenser and S2. So, this is technically H at what temperature? 40 degrees Celsius and 1.5618 kilojoules per kilogram Kelvin. Okay, tinuruan ko na naman kayo noon sa klase kung paano kumuha sa chart. So, ang nakuha ko is approximately 373.82, no? kilojoules per kilogram. Okay, so yan na po yung ating values. And then now we can compute, no? So, going back sa ating requirements, so sulat ko na lang dito sa gilid. Letter A, we're looking for refrigerating effect. Okay, letter B, we're looking for work. So technically that is work of the compressor. And then letter C, we're looking for the heat rejected. And letter D, we are looking for what? For COP. Okay, so since meron na tayong mga given, we can solve na naman, no? Okay, for our solution, letter A, for refrigerating effect is technically QA, no? Walang mass, no? So that is in terms of enthalpy lang, no? So technically, no, yan ay QA over mass ng refrigerant. So true enough, wala namang binigay na mass sa refrigerant. So pwede natin expression as enthalpy na lang. So we have MR for our previous videos, that is H1 minus H4 over MR. So cancel this out. So we have refrigerating effect is simply H1 minus H4. And then we have value of H1, that is 350.56 minus H4, 239.22. With the aid of your calculator, we will be having refrigerating effect as what? 111.34 kilojoules per kilogram. Okay? Letter B. We're looking for work, no? So, this is work na compressor. So, technically, medyo maliit lang, no? Kasi, again, work na compressor per kilogram is work of the compressor per mass of refrigerant. Again, what is the work of compressor? From our previous video, that is mass of refrigerant times what? H2 minus H1. Anyway, kung nalilito ka, pwede naman kayo mag-energy balance over mass of refrigerant. Cancel this out. So, you have what? H2 minus H1. So, this is what? H2, I have 373 point, sorry for that. Okay, barahin lang natin. Okay, so we have 373, okay, 0.82 minus H1, that is 350.56. So, again, with the aid of calculator, we will be having 23.26, so that is kilojoules per kilogram mass of refrigerant. Okay, for letter C, again, kung nalilito kayo, pwede kayong mag-energy balance. So, gagawin ko sa mga susunod na example, okay? For letter C, we will be having QR. Okay, QR. So, medyo maliit siya. That is, again, QR over mass ng refrigerant. Okay, ang system natin for heat rejection is yung ating condenser, no? So, that is MR times H2 minus H3 all over what? Mass ng refrigerant. Okay? So, that is what? Cancelled out to, no, mga kapatid. So, we have H2 minus H. Technically, this is 373.82 minus 239.22. So, we have heat rejected per kilogram mass is 134.6 kilojoules per kilogram mass. And then, finally, for letter D, we will be having COP, no? So, that is what? QA over work ng compressor. So, that is what? Pwede siyang mass ng refrigerant times yung QA, maliit, no? This is per kilogram kasi, no? Over mass ng refrigerant times ng work ng compressor. So, per kilogram din ito. Cancel out this one. So, we have QA over work ng compressor. So, technically, QA is also yung refrigerating effect over work ng compressor. O, since na-compute naman natin, gamitin na lang natin yung values computed. So, we have 111.34 over work compressor, that is 23.26. And dividing these two, we'll be having 4.79 as your COP. Or remember, no, COP is a dimensionless unit. So, these are the final answers. So, again, thank you for watching, and next video is another example for vapor compression cycle. Thank you.